Hello friends, how are you? In last class we completed our chapter number 7th, which was atomic structure, periodic table and periodicity of properties. Okay, I hope you understand about that. Now I'm starting our chapter number 8, that is carbon and its compound. That is carbon and its compound. If we consider the importance of carbon in our daily life or in our life, then we can say that all the living organisms on earth all the living organisms on earth are carbon based. That means we are carbon based organisms, because our essentials requirements and non essentials requirement, that means primary or secondary requirements, primary requirement, that means food, and secondary requirement like the clothes, shelter, etc., all are carbon based. All are carbon based, because the requirement like the food, that may be carbohydrate, protein, fat, etc., are made up by carbon. All of these are made up by carbon. Other than food, other than food, various other things like wood, plastic, cloth, oil, soap, petrol, LPG, etc., are compounds of carbon. That means our primary requirement as well as secondary requirement. Secondary requirements. All of these are dependent on carbon. That's why we can say that all the living organisms on earth are carbon based. Are carbon based. Got it? Now, let me consider the vital force theory. Our first topic of chapter is vital force theory. According to Berzelius, the organic compounds are formed by living organisms only. According to Berzelius, the organic compounds are formed by living organisms only. That means we cannot synthesize the organic compound by any artificial method. We cannot synthesize the organic compounds by artificial method. It is called vital force theory. It is called vital force theory. Okay, this theory was much popular in the past, but in 1828 F. Wooler F. Wooler discarded this theory. He discarded this theory by making organic compound urea. He made organic compound urea in lab by inorganic substances. By inorganic substances. He heated ammonium sulfate and potassium cyanide. Cyanate, sorry. He heated ammonium sulfate and potassium cyanate, which gives urea. Which gives urea. That is, it is ammonium sulfate and it is potassium cyanate. When they heated, they forms ammonium cyanate, and on heating, ammonium cyanate decompose and gives urea. In this way, he made inorganic compounds. He made organic compound urea from inorganic compound in the lab. By this, the vital force theory, according to which the living organisms can produce organic compound, is discarded. Okay. Now, let me consider the properties of carbon. Let me consider the properties of carbon. The first property is the atomic number of carbon is 6 and denoted by C. The atomic number of carbon is 6 and denoted by C. Because if you consider the periodic table, then carbon is placed at 6th number. Hydrogen, helium, lithium, beryllium, boron, carbon. Okay, so it is placed at C. It is placed at 6 and the symbol is C. Its electronic configuration is 1s2 2s2 2p2. Its electron configuration is 1s2 2s2 2p2. There are six electrons in carbon. because its atomic number is 6, so it has 6 electrons, and these 6 electrons are distributed like 1s2, 2s2, 2p2, or if we consider the shell or orbits, then that are in 2 electrons in k shell and 4 electrons are in L shell. Okay, now the valency, since it has 4 electron in outermost shell, it has 4 electron in outermost shell, and you know that for stability every atom wants 8 electron, every element wants 8 electrons, so its requirement is 4, so it can share 4 electrons, that's why its valency is 4. Okay, that means we can say that carbon is tetravalent. It is tetravalent. It combines with other element to satisfy valencies in following ways. Here, carbon can satisfy its valencies by various methods. That means he can choose any of the following ways by which he can satisfy its valency. First one is by combining with 4 monovalent atoms. He can combine with 4 monovalent atoms. He can combine with 4 monovalent. Mono means one. Valent means valency. That means the element who make single bond with carbon, that are monovalent. Okay, so by combining with 4 monovalent atoms like the methane, CH4, and CCl4, CCl4, carbon tetrachloride. Here carbon combine with the 4 hydrogen which are monovalent, and second carbon tetrachloride, or that is also called tetrachloromethane, in which carbon is combined with 4 chlorine atom by making single bond. So by combining with the 4 monovalent atoms, carbon can satisfy its valency, tetravalency. The second way that have carbon have, that is by 2 monovalent and 1 divalent. That means by combining with 2 atoms which can make single bonds and 1 atom which can make double bond. Okay, for example formaldehyde, in which carbon combine with the two hydrogens making single bonds, and 1 oxygen by making double bond, so that is divalent, and these are monovalents. Got it? Third, by 2 divalent, because if combined with the 2 divalent atoms, then 1 divalent satisfies 2 valency, so 2 satisfy its 4 valency. For example, carbon dioxide, in which carbon combine with the 2 oxygen, and each oxygen satisfy its 2 valency, so both oxygens satisfy its 4 valencies. Got it? Next one is by 1 monovalent and 1 trivalent. By 1 monovalent and 1 trivalent, in which it combine with the 1 atom which can make single bond and one another which make triple bond. For example, hydrogen cyanide, in which carbon combine with hydrogen and singly bonded with hydrogen and triple bonded with nitrogen. Got it? Clear? Now, the next property is geometry of carbon. Geometry of carbon. The carbon geometry is tetrahedral. The geometry of carbon, regular geometry of carbon is tetrahedral, in which its 4 valencies are directed towards 4 corners of a regular tetrahedron, and carbon is at its center. The bond angle of this arrangement is 109 degree in 28 minutes, or we can also say that 109.5 degree. Okay, this is the example, that is the tetrahedral geometry of methane, in which carbon is placed at the center and its four valencies are located toward the tetrahedron, four corners of the tetrahedron. Got it? Now, and one more thing, the bond angle will be 109 degree 28 minutes, or we can say that 109.5 degree. Got it? Now, in this point we discuss two topics, that is tetrahedron and bond angle. So we will discuss about that. What is tetrahedron? It is a shape. It is a shape in which four triangular faces are present. There is four triangular faces are present. One of these face is base, and three other are joined to an apex. In this arrangement, one of the face, there is four triangular faces, out of which one is base and three other are joined at apex. Got it? If you consider this, carbon is here, one valency, two valency, three valency, and fourth, it is for suppose to understand it, you can consider that these three valencies are on paper and that fourth one is outside of the paper, and when we combine them with the carbon, then there are four triangular faces. One, that is first triangular face. By combining that and that is a second triangular face. By combining with that one, that is third triangular face. Okay, and that is fourth triangular face, out of which one is base, okay, and remaining three join at an apex. That one base, this is its base, this triangular is base, and remaining 1 2 3, these combine at an apex. This structure is known as tetrahedral. It is called tetrahedral geometry. The second term which we used in above topic, that is bond angle. The angle between two adjacent bonds, the angle between two adjacent bond in a molecule is called bond angle. These are two adjacent bonds and the angle between them, this is called bond angle. It is called bond angle. Got it? Now, let me consider fifth property of carbon. This is very important for our exam. Let me clear you, that is, it is a very common question for our exam. Carbon has a unique ability. This ability generally do not found in other elements. Only a silicon element has some slightly, or we can say some amount of this property. So it is a unique property which is found only in carbon. Got it? So carbon has unique ability to bond with the other carbon atoms and make linear, or we can say that unbranched, second branched, or third one is cyclic compounds. That means carbon combine with the carbon and can make three type of structures. Linear, that means in which carbon atoms are arranged in one by one like a line. Second, that is branched, in which one line and one or one more than one carbon atoms are just in the side. And third, that is cyclic, in which the last carbon is attached with the first one. For example, this, that one, that and the last one is again attached with the first. Similarly that. So this is property is known as catenation. To understand more about it, let me consider the examples. First one, which is example of linear arrangement, that is butane. The naming of these elements we will discuss in upcoming videos. Okay, here we are just generally describing about that. Butane, in which four carbon atoms are arranged end to end. Four carbon atoms are arranged end to end. That is a line, just like a line. This is called linear arrangement. Here, that are branched, in which some atoms are arranged in lines and some carbon atoms are as side lines. Okay, so that is similarly this one, that is line and that are sides. Okay, so these are called branched arrangements. Third one is cyclic or ring. Cyclic or ring, in which the last carbon again combined with the first one. This one combined with the first, say this one, this and this last one again combined with the first. So that is a ring. That is a ring. Got it? Like the cyclohexane, similar thing is here. Six carbon atoms are combined in a ring. That is benzene. Here again six carbons are combined with each other. Got it? So these are called cyclic or ring. Got it? Sixth property of carbon, that is carbon atom can make single, double or triple bonds with each other. Carbon atoms can combine, make single, triple or double bonds. Here we are considering only the bond between carbon atoms. Okay, like this, carbon can combine with those other carbon atom single bond, by double bond, by triple bond. If it is combined with the single bond, then they are called alkanes. If double bonds, then alkenes, and if triple bond, then are called alkynes. Y-N-E sound, that is ine, alkynes. Got it? Now the next property, that is electronegativity of carbon and hydrogen are almost same. The electronegativities. What is electronegativity? The tendency to attract bonding electrons. We discussed in previous class about that. The tendency to attract bonding electrons is known as electronegativity. So the electronegativity of carbon and hydrogen are almost same. That is almost same. Got it? So they make strong covalent bonds, because if electronegativity is same, then the bonding electron will present almost in the middle of the two atoms, which is the condition of strong covalent bond. So carbon and hydrogen make strong covalent bonds. In this, the carbon and hydrogen share electrons. In covalent bond, carbon and hydrogen share electrons and attain the noble gas configuration, in which their shells their shells, or we can say that valencies, get fulfilled. Okay, in this sharing, the carbon attain the configuration of noble gas neon, while hydrogen attain the configuration of helium. That means 2 electron in the outermost shell of hydrogen, while 8 electron in the outermost shell of carbon. So by sharing, they attain this configuration. How will they attain? To understand, we can take some example. Here we are discussing the electronic formula of few compounds and describe them by electron dot cross structures. Okay, before starting that point, let me clear you what is the electronic config formula or electron dot cross structure. If we represent the electrons of outermost shells and bonding. To describe the bonding, when we use the representation of valence electrons of outermost shells, then it is called electronic formula. Okay, an electron dot cross structure in which an atom is represented by a circle and its outermost shell's valence electron, that is outermost shell's electrons, are represented by dot or cross, that structures are known as electron dot cross structures. Okay, now here we discuss some electron dot structures and try to understand the how the atoms attain the stability or fulfill their outermost shells, or we can also say that how they combine with each other. Okay, I am first considering the example of methane. The one thing, these lines are in the chapter 19, chapter 12, that are methane, that is main component of CNG. It is very very important for us in general exams. In exam generally this question is asked that make the dot electron dot cross structure of methane. Make the electron dot cross structure of methane. Or sometime it can ask that write the dot cross structure of main component of CNG or biogas or gobar gas. Okay, because it is the main component of them. Now here we represent carbon by a circle, okay, and hydrogen with also with their circles, and there we represent the sharing of electrons, that place showing the sharing of electrons. Clear? Carbon, and there are 4 hydrogen. Hydrogen can share 1 electron only. Hydrogen can share 1 electron only. Why? Because it has only 1 electron, so it can share 1 electron. So whenever the hydrogen combined with any element, then it may always form a single bond. Clear? So here we denoted carbon by circle and there are 4 hydrogens. Okay, now showing the sharing hydrogen electron by the crossing. It's matter of us that we use dot or cross with anyone, but one point let me clear you that when there is sharing between the same atoms, then same sign is used to denote their electrons. That means if there are two hydrogen, then both hydrogen electrons will show by either dot or by cross. But if there are different atoms, then electrons of one element are denoted by dot, while the electrons of other element are denoted by cross. Like here, one is dotted and one is crossed. Okay, so hydrogen share one electron and carbon share one electron. Similarly, carbon share one electron with the 4 hydrogen. Carbon share one electron with the 4 hydrogens. Got it? You know that in covalent bond, the sharing electron will count with both atoms, because in covalent bond, the shared electrons, the right of shared electrons will consider on both atoms. So here these shared electrons will count on hydrogen also and carbon. Similarly, these shared electrons will count on hydrogen as well as this carbon. Similarly there. That means these two electrons will count hydrogen as well as carbon. So if we consider the electron configuration then? Hydrogen attain helium configuration because now it has two electron, one of which are shared electron. Okay. Similarly, this hydrogen also has two electron, that is helium configuration, this one and this one. That means all the four hydrogen attain helium configuration. That means they are stable now. Now consider the carbon. By sharing it, now it has 8 electron. These 2 electron, there 2, there 2 and there 2. So now its outermost shell is 8 electron. Outermost shell becomes 8 electron, which is the configuration of neon. That is another noble gases. That means by sharing, both hydrogen and carbon attain noble gas configurations. That means stability. Clear? Now, if we make its structure formula, that is electronic formula, and that is its structure formula, then since they are sharing one electron, and sharing of one electron makes single bond, the sharing of one electron makes a single bond. So there carbon combine and make 4 single bond with 4 hydrogen atoms. Got it? The second example of today's class about the dot cross structure, that is ethene. That is ethene. The chemical formula, the molecular formula is C2H6. That means there are 2 carbon and 6 hydrogens. 2 carbon and 6 hydrogens. Both carbons are denoted by these two circles, and each carbon has 3 hydrogens. Now the first question that come in our mind, that how can we decide it? Before I am discussing about that, and then the same thing will come in our mind, that how can we know that how many hydrogens combine with that? How many hydrogens will combine with that? To understand it, let's consider, look towards my hand. There are 2 carbon atoms, and valency of each carbon atom is 4. So we have to satisfy the 8 valencies. We have to satisfy the 8 valencies, 4 of that carbon and 4 of that carbon. We have only 6 hydrogens. If I consider that one hydrogen is present on one carbon atom, so as you know that one hydrogen satisfy its one valency, that one. Similarly, another, that one, 2 hydrogen used, that one third, that one fourth, that one fifth, and that one sixth. Now 6 hydrogens, 1 2 3, 1 2 3, these are satisfied, these are combined with carbon. Now both carbon has one valency, which they can use to make a single bond between them. Got it? So in this way we can identify that how the valencies will satisfy and how many bonds will formed between the carbon atoms. Similarly, here we can consider one more example to understand it, that is C2H4. Again 4 valencies, 4 valencies, 8 valencies, hydrogen is 4, 2 2, 4 hydrogen used. Now both carbon has 2 valencies, which they can use to make a double bond, that one. Similarly, that 4 8 valencies, now there is 2 hydrogen, combine one hydrogen on both carbon, and now the remaining that have 3 3, so they combine and make triple bond. Got it? This is the simplest way to understand about it. Okay. Now let us discuss their electronic configuration, electronic formula. Here two carbon atoms and each have six hydrogens. Sorry, each have three hydrogens. They make single bond. By making this single bonds, the three valency of that carbon satisfied, three valency of that carbon satisfied. Now both have one valency, so they also combine with each other and make a single bond. Got it? So its structure formula becomes carbon singly bonded with the three hydrogen, that carbon singly bonded with the three hydrogen, and these two carbons also singly bonded with each other. Got it? Second one is ethene, C2H4. Here each carbon has two hydrogens, so its two valencies are satisfied. There two valencies are satisfied and two valencies are remaining. To satisfy these valencies, both carbon make double bond. That means they share two electrons. They share two electrons by each. That one from that carbon, that one from that carbon. So the sharing of two electrons make double bond between them. Okay. Now third one, that is ethene. Ethine, sorry. Ethine. Ethene we discussed. Ethine, that is C2H4. The fourth one is ethine, that is C2H4, where one hydrogens are present. One hydrogens are present on both carbons, so they make single bond. Now there is three valencies remaining. There is three valencies remaining. To satisfy them, both carbons make triple bond. Both carbon make triple bond. Got it? So there is triple bonds. So the structure becomes carbon singly bonded with the hydrogens and triply bonded with each other. So this is the structure, the structural formula of ethene. This is the electronic formula of ethine. Sorry, that is the structural formula of ethine, and that is the electronic formula of ethine. Similarly, above one, that is electronic formula of ethene, structure formula of ethene. One thing let me clear you, this is very important question because board that is generally asked by examiners. Write the structure formula of methane, ethene, ethine, etc. Now what is organic compound? What is organic compound? The first definition is on the basis of vital force theory, according to which the substance which obtained from living organisms are called organic compounds because they are obtaining from organism. That's why they are called organic compounds. And their study was called or was known as organic chemistry. That is old definition. And now if we consider the modern definition, then you can understand that carbon has four valencies. To satisfy it, the carbon atom combined with the other carbon atoms or hydrogen, nitrogen, oxygen, sulfur. There are lots of other elements. So carbon fulfill their valencies by combining with the other carbon, hydrogen, nitrogen, oxygen, etc. and make large number of molecules. These carbon containing molecules are called organic compounds. That means if we consider the modern definition or the simplest definition, then we can say that the carbon containing molecules are called organic compounds. And the branch of science which deal with the branch of science which deal with the study of organic compounds, the branch of science in which we study about the organic compounds is known as organic chemistry. Is known as organic chemistry. Okay. Out there are lots of organic compound. Approximately there are 3 crore or 30 crore. There is a small doubt in my mind, but I think there is 30 crore or maybe 3 crore organic compounds. It and the remaining 118 elements make only 10% of that figure. Now you can understand the importance of organic chemistry in our life. Out of these, there are lots of compounds. Out of these, one, that is hydrocarbons, are in our syllabus. We will discuss about them. Here I am discussing the definition. Very simple definition: hydrocarbon, that means compound made up by carbon and hydrogen. Compounds which are made up by carbon and hydrogens. Got it? So we can say that organic compound formed by or made up by carbon and hydrogen are called hydrocarbons. Their classifications, their nomenclature, and other things we will discuss in next video. Hope you like it. Thank you.